So can you start off saying who you are and your profession?
My name is Kevin Meyers. I'm a math teacher at the Wheatley School.
What are imaginary numbers?
Imaginary numbers are anything that's multiplied by the square root of -1 or anything with a square root of a negative number.
How is a non-existent number used in math?
Well, actually, imaginary numbers first started being used to explain phenomena that happen in the real world. The thing that happened was people would use hair dryers in apartment buildings and power would go out. So we're trying to find a way to explain that. And what they found is that current actually changes phase. There's a real phase to current and an imaginary phase to current. So whenever the hair dryers were used, the current would change phase and more current was being drawn, and that would blow out the fuses in the whole apartment building.
How can a complex number possibly be a root of an equation?
Well, anything could be a root of an equation, just a matter of what makes it work. So in the cases that you're talking about for the imaginary roots, these are numbers that when you needed to get a negative answer when you squared something, that's why they work as opposed to just a straight number. Because sometimes you need the x squared to be -2, let's say, and that's why the imaginary numbers will come into play.
That seems to mean that the roots don't exist, but there are roots though. Can you explain this?
When you say they don't exist in the real number system. They exist in a complex number system. And that's really, it's how you really define the game. In the graphs that you've always seen in school, they've always been Cartesian planes where x and y are both real. But if you put it in a complex number system, those answers are real and you can plot them.
In what ways is the ability to do math dependent on a good imagination?
I don't know if that's necessary. I wouldn't say this, you need a good imagination. I think experience kind of helps, that the more problems you see and the more types of problems you see, the better off you're going to be. So I think that's more than an imagination. It helps to be creative, but I think the people I've seen who are creative are the ones who've seen problems that they couldn't do and have learned how to do them, and that they look creative because they're able to take what somebody else has shown them and use them.
Okay. Do you want to ask this question? Because we already said used in math.
Yes.
Okay. How are imaginary numbers used in geometry, and what is a Mandelbrot fractal?
It's not really used much in Euclidean geometry. Most of the time, if the answer came out to be complex or imaginary, the answer, like you said, would not exist. As far as fractals go, the graphs of fractals are done on a complex number plane. And they normally start off with z equals a plus bi, and there's a multiplier and an adder, and then a multiplier, and then they figure out the next point. And I hate to say it, but it's like connect the dots. The only difference is that to connect the dots is not with 1 to 2 to 3. It's like 1 plus I to 2 minus I, or 3 minus 2i. So the complex, I guess it's complex number dots. How's that?
Which particular math studies requires the most imagination?
Most imagination. It's funny because I don't consider math to be a very imaginative thing. I think of it as a game that people play by certain rules, and if you change the rules, the game changes totally. So like the stuff we've been learning is Euclidean geometry in high school. If you change it to the non-Euclidean, the game changes totally. I wish I could show you with a nice demonstration of, look, it changes, but the reality is it's a game set up by rules, and people play by the rules. And once you change the rules, everything goes out the window, or the whole game changes.
Okay, thank you for your time.
You're welcome.